All right. Hi, everyone. I welcome all of you. Today is the sixth session of Fun with 3D initiative, which is launched so that all the students who are participating in the STFE program will get mastery over X design or will get mastery over CAD modeling so that they can create their dream product, CAD model of their dream product in X design. So we are here working as a bridge so that you will be expert in X design. Talking about myself, I am SolidWorks training specialist. SolidWorks is a CAD software. So my area of expertise is 3D designing along with X design and SolidWorks. So I have 10 plus years of experience working as a computer aided drawing expert and as well as a CAE. CAE is like computer aided engineering. So in real world, it's not only we design or we create something in CAD. Actually, we go beyond that. So what we do once we create a CAD product, we try to do simulation of it. We try to test it in the virtual world. So I have that experience as well. So what is the goal of these all these sessions? Our goal is to make you master in X design. You should be in a position so that you can think of any dream product and you can try to create its CAD model yourself. So we are there to help you on this. You can connect me via this email ID sagar.sutar@3ds.com. If you have any queries, your school, if you have any queries related to X design, or if you stuck somewhere while developing your product, you can always connect back with us. We will try to see your query. If possible, we will help there. Most of the time we get queries get resolved within one or two calls. So I request all teachers and students, please note the email ID and you can connect back with us. So in today's session, I have one of my colleague, Mr. Rishikesh Awad sir. So he is there who he will handle Q&A section panel. So as you can see in your Zoom window, there is a Q&A section, and from there you can put your queries in that panel. Please wait. What is the flow that we will complete the session and then you will add your queries. So Rushikesh is there who will handle your queries while I'm conducting the session. So I think Rishikesh, you know Rishikesh because he has conducted some of the sessions already. He was school champion last year also, and this year also he's a school champion. Apart from that, he is helping us in conducting X design sessions. He's expert in X design. So he's a user success engineer working at Dassault System Law Foundation. What does it means that he support CAD software such as SolidWorks and XDesign. If the customer raises any query, he is there to answer that queries. He has almost 1.6 years of experience working as a CAD technical support specialist, and he is there to make you expert in X design. All right, I want 100% participation in this today's webinar or today's session. I don't want it one way. All right, so this is all about Rishikesh and myself. Let us see the agenda for today's session. Our agenda is quite easy. We will just take a quick recap of session 5. Then we will do couple of hands-on challenge, and we will post one hands-on challenge as an exercise for you on the community. And then we will take the recap and what will be the next session. We will discuss about it. All right, so let's start with what we covered in session 5. So in the previous session, which was conducted on Monday, November 10, it was conducted by Rahul and Rishikesh and Ishwar were there to answer your queries in the they were helping us in Q&A section. So what it was conducted, it was regarding what is assembly, how to create or open an assembly in X design, how to insert a part in X design, and how to create few simple mates. So in today's session, we are going to cover that as well, and we will take some of the challenges. Like this one is challenge where we need to create this kind of screw jack assembly. So in the Q&A section, you can provide your answer. Do you know this screw jack assembly? Have you seen this? Do you know where do we use it? You can answer it in the Q&A section so that I can take a look at your answers. Okay. Lifting cars, Chinmay has currently explained garages. Yes, to lift cars. Okay, absolutely correct. So this kind of device we use it to lift our vehicle. So we are going to assemble this. How we can do the assembly of this, that is I'm going to demonstrate. So please, if you are doing anything else, please stop and just focus on what I am going to do here in X design. So for you, here I have opened that part in X design. Not the part, it's a car jack assembly. I have opened it in X design. Okay, and you can see there are so many mates I have added. We are going to add those kind of mates, but before I want to show you how we can add it, I want to just demonstrate how this car jack, if I just lift it, you can see the movement. So all this assembly that we want to learn how we can do it. All right, you can see if I put some weight on this and if I rotate this, it will go up like this, it will go down like this. So this kind of mechanism or movement we want to simulate, and to do that we need to add mates. So these are the mates that we need to add. So for now I will delete all these mates. So now there is a no mate in the graphics in the design manager. So to demonstrate you, if I remove any part, you can see I can disassemble it. So all the mates are removed and we have just parts in the graphics area, and now I want to mate them. Understood? So let us try to mate one by one each part. So what we will do, see, I will control select, I will select this face, then press control key and select this face and release it. And I can see this circular mark, that's it, concentric mate. I can add it. I think the same mate was covered in the previous session. So again, we are going to use that mate. Second thing, I want to mate this part with this face, or I want to attach or put coincident mate. So I'm adding coincident mate between this face and this face. So far I have added two mates, and you can see these two mates are there under revolute joint. So these are the two mates that we have added so far. Again, this face and this face, I will control select and add coincident mate. Similarly, this part, if I move it, I want to add coincident mate between these two circles. Control select, press release key, release control key and press concentric. In the same way, the concentric mate gets added. I want to mate this part with this part. Just control select the faces, release control key, and you will see the various options. Press coincident, automatically the face gets selected. But notice that I want to mate this face with this face. Again, this way I can mate it. All right, now this face, see, one by one I am going to add those mates so that my assembly will be complete. Okay, so I think left part is done. Let me check. Yeah, I have to add this rod or this connecting linkage here. Concentric mate. Okay, and in the same way, control select these two faces and release again. concentric mate. Now what is the problem? I want to mate this part with this face. So this way, but this part and this part. Now it is looking okay. So same way I have to add mates on the other side. As you can see, I can move these parts here. So what I will do, I will add coincident mate here. In the same way, I will add this face and this face coincident mate. See, then this face must be touching this face. All right, and what we can do, we can add concentric mate between these two faces. Similarly, this face and this face. All right. Similarly, I will add this face and this face. See, I have to add repetitively coincident and concentric mate to align this. Though it looks a tedious job, but we have to be patient and we need to do it one mate at a time. We need to add. All right, let's try to move it. Okay, it's going okay, but see, this face, the circular face and this circular face must be coincident. Now if you try to simulate, let us see how it is going. Okay, so this has a lateral movement which is not right, so I will select this face and this face, so those will be coincident. Now if I try to simulate, okay, it's going in a right way, but this face and the circular face, those are not coincident. Let's add that. Now see, all are moving okay. Same way if I do it here, all are moving okay. Now what I will do, I will add coincident mate between these two, concentric. In the same way, first I will add concentric. See, I'm going to add concentric mate between these two faces and concentric mate between these two faces. All right. In the same way, I will add this face and this face concentric mate. Okay, now what is the problem? I want this part to be flat or parallel to this face every time. So I will add parallel mate here. Now if you want to simulate, you can see this is how it is moving. Now I have to add screw rod at the center. So I will add concentric mate here. At the same time, I will make this face with this face. Okay. Now again, this face and this face must be concentric. What happened? The basket is incorrect. So okay. Okay. So this face and this face. Okay. Last mate we just need to add so that it will get assembled. So just a minute. Coincident. I will just deactivate this. And what I will do, I want this. See, if you select any mate and click on this deactivate or deactivate mate command, it will deactivate that mate. I will remove for now. I will just this parallel mate also I will deactivate. Right. Okay. So now it is perfect. I will just make this part transparent. And what I will do, I will select these two parts and make it concentric. It's not. The Yeah, let us try to add this mate so that it will be firmly fixed. Okay. And about this rod, uh, selecting this face and selecting this face. Mhm. Not okay. What I will do here, I will try to create some axes so that this rod, okay. Another thing is we can make this face and this face parallel every time. What I will do, I want this face to be vertical all the time. So I will add parallel mate here. All right. And at the same time, for this mate, this face and this face, I will add parallel mate for now. And now you can see, it was asking for one more mate. Then now all the issue has been solved. Now you can see, if I, the only thing is the two rods are not in sync. So what we have to do now, we want this part and this part as coincident concentric, but it is okay. Fine. Now if we just do this, yeah, so this part is a lie, this part is mated, but still uh, the movement is not it's not the way we want it, isn't it? If the screwdriver wants to lift it, it should lift the part in symmetric way. Currently it is not lifting in the symmetric way. So what can be the possible solution? I'm just checking. So I'm trying to make this parallel to one another to see if that works. And if I try to resolve, and now if I check, okay, it's working fine. But okay, if I select this edge and this edge and make it roll curve, no, no, it's not gonna work. Okay, so only the rod, this part is this part is mated perfectly. The only thing is uh, the no, the length of rod is correct. That shouldn't be the case. Everything is just fine, but the some sort of tilting motion is there that we don't want. So to avoid it, actually this part and this part should be concentric, but if I apply concentric mate, it is throwing other errors. That's the problem. Otherwise everything is just fine. Here you can see, here is the another problem, but let us see. Now if I drop it like this, okay, we try to solve this in another way. I will just hide this part and make these two circles concentric. Now I think it should solve it, but some of the mates are try to resolve it. Okay, it should be fixed. Just couple of clicks and it should get fixed. Don't worry. All right, I'm going to just editing the mates and try to fix the problem. Oh, where is the second problem? As you can see, it should, if I recalculate, it should fix everything. Global resolve. Okay, it is still giving the error. As you can see, the parts are mated correctly, still this and this face. And if I click OK, see, I'm just editing it. Sometimes the software throws you error. Don't worry about it. You have to edit it and just need to redefine the faces. If I click OK, Okay, so this face and this face. So user define coincident to. Coincident to is just fine here in this case, but still it is throwing error. We can just select this face and this face and click OK. Where is the another error? Here is the not here. Here is the coincident mate is the error. So this face and this face. Just a minute. Added. What else is here? Coincident mate. Mm, see, again I have to add it. So not here. This face and this face. Okay. Revolute error. Revolute joint. So coincident and concentric both errors are there. See, we have selected the correct faces, still it is showing error, but don't worry, we will reselect it and click OK. Now the last error is concentric. Where is the error? At the bottom face. Click edit and try to select the faces one more time. This face and this face and click OK. Which error is still there? Otherwise everything is solved. Okay, this error is still there, that we will fix it. What was the error? It's a concentric one. Okay, so we will select the correct. Still, we have selected the correct faces. Still, it is showing the incorrect faces. I think we have resolved all the queries. Still, one by one. Okay. Coincident. Okay. What I will do for now, I will just suppress this and suppress this. Okay, now I have suppressed some of the mids and make this turn mode on and try to see how it is working. Now you can see it is working just fine, but some of the mids I have to again add it. Okay, so in this case, uh, this rod is running okay. Only thing is okay. If you want, I can add a symmetric mate so that everything will run smoothly. Let us see, symmetry mate is here. So let's try to add that. So symmetric plane, I have to create symmetric plane in that case. So let us first add a symmetric plane. Here is the symmetric plane and I will go to assembly, try to add symmetric mate here. And this is my symmetric plane. This part and this part. Let us try to add it, add a symmetry. Okay, so now you can see how this everything is working smoothly. So the things were two ends were there, but they were not symmetric. That's why we were getting errors and problems. Now I have added symmetric weight so that everything is running smoothly, and I can add this face and this face to coincident, and now you can see the simulation. So if I this way the screw rod works. The only mate that we wanted to add was a symmetric. Instead of adding symmetric mate, if I had added I was trying to add coincident mate between this circular rod and the hole, but it was throwing some errors. That's why I have to do workaround, and workaround is working fine. So I have added symmetric mate, and now you can see how the assembly is working. All right. Okay, so this was our first challenge, and you can see there are n number of commands we need to add, n number of mates we need to add. So the session is being recorded, so you can refer this session later on, and you can see how the different mates were added. All right. So I will save this part and move on to the second challenge. So the second challenge is here. We want to create some um, worm gear assembly. So we will see how we can make it. I will close this part and go to this worm gear assembly now. So, so this is the worm gear assembly. I will make this transparent to show you, like, there is one rod and there is a circular uh, worm gear. This is worm gear, and the upper part is shaft. So when uh, the worm gear rotates, the shaft will have translatory motion. Are you getting my point? So this kind of assembly is there. So this kind of assembly is there. Uh, so you have seen such type of, so this kind of thing, and most important use is like, you have a rotor, and the for the gate the rotor motor rotates and the gates have linear motion, automatic gates. So automatic gates, if you see, uh, if I have GIF, let us see. So you have seen such gates where these gates will, when motor rotates, this will slide towards right, and when the motor spins in opposite direction, the gates will close. Not in this way, it will sliding motion. So that kind of motion, um, that kind of, so we have linear motion, but motor is a rotary motion. So the worm gear, what it does, so if the worm gear rotates, this rod will have translatory motion. So this kind of assembly, we want to do it. We will see how we can fix it. We have used so many mets. So first I will delete those, and I will, we will restart this model. First, I will change the transparency of the model, and I will move each part. You can see how many components are there inside these parts, inside this assembly. This is your worm gear. So this part is called as housing. So remember, we have to fix at least one part, and that is the starting part. We need to fix it. And with respect to that, we are going to add many other parts. So the first thing is we have to place this worm gear inside this part. So I will select this face and this circular face and add concentric mate, sorry. Then where I want it. I want this part to, okay, this one is the first part. I have made it concentric. Then this part and this part should be concentric. All right, I will add coincident mate between these two faces. See what kind of detail we want here. Now you can see these holes. If I rotate it, it is going to rotate, but I have to match these holes. So I will select the inner hole, control select the other hole, release control key. You have so many options. I will select concentric, and now the part is being fixed. Now the next thing is I have to make this face and this face as coincident. So worm gear is placed inside. Now I will add a concentric mate between these two faces. Similarly, what I will do, I will select this face and this face coincident. See, one step by step, we have closed the back door. Now we are closing the front door, and I have to make these holes. So see, I'm zooming in, selecting the hole faces and releasing the control key, adding concentric mate. That's it. Now I have to put this rod at the center or shaft at the center. So I will control select both the holes or the faces, circular faces, and add it. Similarly, I have to add this face and this face as a coincident mate. And the last part, this shaft should be concentric here. Yeah. And one more thing, what we can do, we can see this way the shaft is there, and you can add this top face and this top face, not exactly. What we can do, we can just match these holes. This hole must match with this hole. See how we are adding the holes. And you all know what we can do. I want to mate this top face with this top face. That's it. So this is how our worm gear assembly is ready. Any questions, queries? And the third exercise is we have to create this piston cylinder assembly. This will be an what you can say an exercise for you. We will add this onto the on the we will post this on community, and you will try to build it, but I will demonstrate the how this mechanism works. Can we stop rod's motion from rotating as well? Oh yes, you want to stop this this the rod is rotating and you want to stop this motion. Yes, you can add it, or you can stop rotating it. For that, you have to expand different planes. And let us say if I make select this plane and make it parallel with this plane, now the rod will not why it's coincident. No, I cannot have coincident. I will add, just a minute, I will add parallel mate here. Now see, since the two planes are parallel, this thing is not gonna move. It will just slide. It will not rotate. Any other question? Third, for the third challenge, I will add it onto the community. But for you, I will just demonstrate how that work. The piston cylinder assembly. That is the easy one, but it has less mates. But I want you to do it. But I will demonstrate its assembly motion, how it works. Just be with me for a few minutes. and I will open it for you. This is your piston cylinder assembly. Completed one. See how it is working. So if I rotate the crank, the piston inside the engine is oscillating. In this case, this part is fixed and the engine is fixed, and you have to add concentric mid between the this piston and this cylinder, and the coincident made between this connecting rod and this the one end of the crankshaft. That's it. Once you do it, and if you try to rotate it, it will have this motion. All right, you can do it on your own. Just 2 mates we need to add, and that's it. You can see what kind of mates. Oh, so yeah, these 2 mates only. You need to add it. Once you add it, you all set. Any question or queries?
So all questions are answered. There were 29 questions
Okay.
regarding overlap of geometry, mates, demonstration of workflow, for
Yeah.
what purpose the structure like worm gear structure is used. So I have answered all that.
Very nice.
Yes.
So you can, friends, um, you can practice this on your own. I have demonstrated how this works. So the I will post this exercise on the community, and you try to create this assembly and try to simulate what I shown. Yes. Yes, so the X design is a cloud-based solution. You need internet or browser-based solution, so you need internet connection constantly to work on this. Yes, sir. Interior, interior of the, yes, you can see the interior. You have to just uh, make this part transparent, and you can see how things are there inside. This is how it is inside. You can make the part transparent. Select it and remove translucency. Select it and make translucent. Translucent. If you click it, it will become translucent, and you can remove its transparency as well. Any queries? So I'm going to add the third challenge as an exercise on the community, as I demonstrated
So
how the piston
there
cylinder works.
there is one more question, where students can find such parts, like on any website it is
Which
recommended.
one?
So the parts which are demonstrated in today's session.
We will add that onto the community. So you have to log into the 3D experience platform, and there we will post the challenges. So here you can see there is a, now it is loading. It is taking some time to load. Yeah, just a minute. So on the STFE, all it's a common community for all the schools. There we will post all the challenges or the CAD files to practice. All right. Sometimes you also face this problem. Once you log in, there you will have access to this common community, and there you can see the all the posts. Any other query? Meanwhile, I will just try to see if I
No,
can get.
I have answered all queries.
Okay. Sometimes you also get this error. In that case, try to open it in cognito mode. Maybe sometimes there is a cache. Because of that cache, um, you are you are not able to access the community, or sometimes you don't get access to um, X design. See, just now I was not able to get the access. Now I am getting. Are you getting my point? So you can try with cognito mode also in that case. So here is the all volunteer community for all the school champions, and this is the community for all the teachers and students, all the schools. So there we will post the challenges.